Hello! In this video, I wanted to talk about the next 6 months of development. Alright, and I wanted to talk a little bit about a data structure that I love called a three-dimensional circular buffer. Let's get into it. Alright, so this is my progress after a year and a half, or well, more about a year of development. In this part, you can see that there are a lot of bugs. And I wanted to talk a little bit about level of detail and how the circular buffers work. So you can see the level of detail working as I move in and out. You can see that's level 1, and as I scroll out, you can kind of tell that it transitions to level of detail 2. And it works actually very well. Each volume is 500 round voxels, large, cubed, and they each sequentially stack. So you have one on top of another on top of another. So right now I'm using 3 volumes on top of each other, and each one is the circular buffer. Now we'll dive in a little bit into that. Alright, so in this demo, I'm actually using a more current build of the voxel engine that I'm developing to showcase what's actually happening here. So this is a three-dimensional buffer or a volume, and pretty simple. And this, to showcase this, I'll actually rotate the buffer around by using this button. Okay. As you rotate it, you can see that the terrain starts generating in a weird pattern. And that's because it's actually copying these tiny little slices right here every time I press this button. And it moves along the path until it starts generating more and more data. And so, let me actually move down the data structure slightly. Oh, there we go. So you can actually see what's going on here. So, as you can see, it's getting a little bit more complicated now because you can see multiple slices. This right here is the X slice that's being copied, and this is the Y slice. So if you fly down, back down to here, you'll see that this is actually the top of this. This is because the buffer is actually warped on each side. So if I was to do that, it would probably make a lot more sense. I'll show you that pretty soon. But as you rotate it, it will center around a point, which is the player's camera, to make it seem as if it would load around the player's camera. So you can see maybe a little bit more of the action of that, and then you can combine it with also the Z direction. So as it loads, you can actually see it all generate, and it all works. So let's jump into the next. So this is the data structure with using the Modulus operator, which basically makes the entire scene repeat. So as I scroll, you can see that it all repeats, and as it goes, you can see it generates, and then you can go down and up, etc. And since it all repeats, you can see that the actual data structure makes a lot more sense in how it works. Now, to actually program this is a little bit difficult because the amount of offsets, but once it's going, it's very smooth and works very well. So, why am I using a three-dimensional circular buffer? And that is a great question. The reason why I picked this data structure out of all others was because it is a lot easier to transverse rays through, and because of the stacked buffers on top of each other, it's basically an octree in a way, because you have smaller nodes and larger nodes, if you want to call them that. And it makes it super easy to transverse, because you can have large nodes or large portions of the volume that tells the ray that there's no data stored there. So when you start your ray transversal algorithm, you start at the top and you work your way down. And because I'm doing this, this means that full volumetric lighting data can work. For example, sun rays coming down onto the player, like in one of my examples that I showed in my last video, works actually super well. And on top of this, because the voxels can be changed so quickly, it's just as simple as editing the memory in the buffer, then it's displayed to the screen. I can do a lot of updating to the geometry around the player, and that's exactly what I want, because I want to basically make every single voxel in the entire scene a particle. Now that is a lot of particles. Just for a 256 cubed volume, there's over 16 million particles. And I will talk a little bit about that in the next video, and how I was able to run that many particles on my computer. Thank you so much for watching. Bye-bye.